All right, guys, this is going to be the lecture for homework 2, which is going to be adding and subtracting with integers. Take a quick moment to refresh on what an integer is. Integers, remember, are positive and negative whole numbers. I mean, whole numbers are their own category, but that's the easiest way to think about it. Integers are positive and negative whole numbers. So basically, adding and subtracting positive numbers. We actually will be doing decimals too. Good news is if you've added money before, which I know you have, adding and subtracting with decimals is more or less a triviality. So we will go from there. So first things first, let's start off with something basic. I do expect you to remember how to do longhand addition. So let's start off with something pretty trivial. 894 plus 3,207. I would encourage you to pause and try this on your own just for practice sake. You do need to remember how to do this kind of stuff. Remember, you're going to want to line them up. Again, this is something you should already know how to do, just simply doing a quick review. You want to line them up. When you're adding when you're adding, the order you put them in doesn't matter. Large over small, and small over large, irrelevant. When you subtract, the order matters quite a bit. Let's go ahead and go this. 7 plus 4, that's 11, carry the 1. 1 and 9 is 10. 0, carry the 1. 2 and 8 is 10, plus 1, 11, carry the 1, and 1 and 3 is 4, 4,101. It's a little bit dry. The first few videos for the class, guys, are going to be very just boring arithmetic. Unfortunately, this is the stuff most people miss on the tests. You have to remember how to do this stuff. You have to remember how to do it by hand, and you have to be able to do it without a calculator. So keep that kind of thing in mind, okay? So just a quick basic on how to add and subtract, or how to add, longhand, I suppose you could say. So hopefully you're good with that. What we're going to be talking about is what we're doing with integers, which remember means signed numbers. So I would give you 4 examples to think about here. Let's say, I'm just going to write them all out here. Let's say I said negative 74 minus 21. Let's say I also said negative 19 plus 42. Because right now we're talking integers. We'll go with a basic one here, 34 plus 96. And we'll go with the last one here, 57 minus 31. Take a minute and look at these 4 examples. They're all 4 cases, basically. Negatives, positives, negative and positive, 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 negative, that kind of thing. All right. So the issue here is, when do you subtract, when do you add? And again, remember, these videos are optional, so if you're already comfortable with this part, that's fine. But be honest with yourself, because a lot of people goof these up. And even though they think they're on top, and then it's, test one can be a little bit embarrassing. So take an easy one like 36 plus 90 or 34 plus 96, no big deal, just what we just did. 4 and 6 is 10, carry the 1, 3 and 9 is 12, and 1 is 13, right? 130. Why did you add those though? That's really the question. That's what I want you to think about. Why did you add those? It's not because there was a plus sign. That is not the answer. Okay, so think about that for a second. What about this one down here, 57 minus 31? Again, pretty trivial, no big deal. 57 minus 31, 7 minus 1 is 6, 5 minus 3 is 2. Got to write a little smaller to cram that in. Some of y'all said the audio was a little bit loud, so I'm trying to sit a little further back from the machine this time. Hopefully that helps. So 34 plus 96 was 130. 57 minus 31 was 26. And I think you know how to do both of those already. That's just basic addition and subtraction. But again, ask yourself, why did you add here and why did you subtract? It is not because of the sign. It is not because of the plus and the minus, is I guess what I mean. Come over here. Negative 74 minus 21. How would you do that? Would you add those or subtract those? Well, think about it like money. When you're adding and subtracting, think about money. You owe me $74, right? Negative. And now you owe me $21 more. If we were going to sum that up, wouldn't we add those together? I mean, you owe me 74, you owe me 21. You don't have money all of a sudden. You don't get to decrease the debt all of a sudden, right? 74 and 21, we're going to add those together. You get 95. Now, the issue is it positive 95 or not? Well, obviously not, right? You owe me $74. You owe me $21. You owe me $95, negative $95. Why did I add those, though? This is the key point, y'all. Focus in here. Over here, I added, and there was a plus sign. Over here, I just added, and there was a negative sign, right? A minus sign, I guess, if you want to call it. So keep that in mind. And then the last one here, 42, negative 19 plus 42. You owe me $19. You give me $42. How are we going to work that out? Think about what I just said. You owe me $19. You give me $42. Wouldn't we take the 19 off the 42? Wouldn't we subtract here? So squeeze it in right here. Didn't give myself enough room, really. 2 minus 9, can't do it. We got to borrow, right? Don't forget about this kind of stuff. That you are supposed to remember how to do. 12 minus 9 is 3, and 3 minus 1 is 2. So this one would be 23, right? Think about it. You owe me 19. Well, kind of lost that there. There we go. You owe me 19. You give me 42. You're getting 23 back. So take a minute and look at these 4 examples, and we'll write the rule down in a second here. But I just want to make the point. You added, you subtracted, you added, you subtracted. Why? Think about why. Here you added, there was a plus sign, makes sense. Here you subtracted, there was a minus sign, makes sense. But over here, there was a minus sign and you added them. Over here, there was a plus sign and you subtracted them. So I think hopefully, at least at this point, you can agree, you cannot trust the sign. So if you're one of those people who's been getting these about half right, half wrong throughout your life, sometimes when I add subtract, I get it right. Sometimes I get it wrong. It might be because you're going by the sign. Do not add if it says plus. Do not subtract if it says minus. That's not the way this works. I'm going to bump this up just a little bit, try to keep those 4 examples on the paper there. Right? And then underneath, let's try to write the rule down here. Right? What is the rule? Well, think about it. When it said plus, we added. When it said plus, we subtracted. When it said minus, we subtracted. When it said minus, we added. So again, once more, you cannot go by the sign. What you're going to go by, or not the sign, but the operation symbol. Plus and minus cannot be trusted. What you have to go by is positives and negatives. So let's take a look and think about this. Right here, you had 2 positives and you added them. Agreed? Over here, you had 2 negatives and you added them. So couldn't we say when signs are the same, you add? Isn't that really the answer here? When signs are the same, you add. Think about it. Think about the last 4 examples. When we had a positive and a negative, we didn't add. We had a negative and a positive, we didn't add. We only added when we had a negative and a negative or a positive and a positive. Think about money. Debt plus debt makes more debt. Money plus money makes more money. If you have debt and money mixed together, you have to subtract them to find out the total, right? So couldn't we then also say, if the signs are different, negative and positive, or positive and negative, right? Because that does say minus 31, but you are subtracting it. It's $31 in debt. So couldn't we say when signs are different, we will subtract? And ultimately, that really is the answer here. When the signs are the same, you add. When the signs are different, you subtract. And that's really how to add and subtract, or in terms of when to add and subtract. Now, the other issue is what's the sign of the answer? How do you know if it's going to be negative? How do you know if it's going to be positive? We'll go back and look at the 4 examples we just did. And I hate to keep harping on 4 basic examples. We'll do some more in a minute. Think about it. 34 and 96, added them together, made positive 130. Why? Well, because money and money just makes money, right? Obviously. And over here with the debt, you owe me 74, you owe me 21, you owe me 95. So debt and debt makes more debt. Money and money makes more money. Pretty straightforward. What about if they're mixed, though? Negative 19 and 42, that came out positive. 57 minus 31, that came out positive. Wouldn't you agree in all 4 examples that the largest numbers we kept for the sign come up here? 34 and 96, which is larger? Well, 96, right? And it was positive. So is the answer. Down here, 57 and 31. That's not a decimal, it's just a mark. 57 and 31, that's positive 57, that's negative 31. 57 minus 31, positive 26. Why positive? Because 57 was the bigger number, and it was positive. Over here, negative 19 and 42. Again, you subtracted them, but we kept it positive in the end because the bigger number was positive. And here, negative 74, negative 21. Negative 74 is negative. It is the bigger number, so the answer was negative. So what we can say, I'm going to go ahead and move these off now. What we can say, leave this lined up, is that when the signs are the same, you add. When the signs are different, you subtract. And collectively, keep the sign of the bigger number. So take a minute, because these are the rules, right? If all the talking I've done and all the examples I gave you kind of were muddying the water, take a minute, because this is the rules. This should clear it up. If you're adding 2 numbers and the signs are the same, you're going to add them. If they're both positive, they're going to add. If they're both negative, they're going to add. debt plus debt makes more debt. If the signs are different, you have one positive and one negative, that's when you're going to subtract. And then how will you know what the sign of the answer will be? Well, you keep the sign of the larger number. So in general, it's not too crazy, but obviously if you think about it, this doesn't really still solve the problem of the longer issue, of the longer problems, right? So if we did a longer one, let's go ahead and bump that up. If we did a longer one, let's throw this out, because you'll see stuff like this in the homework. And a couple of y'all were mentioning that the homework was a little more difficult than you thought. Remember, the lectures are just covering the generic ideas. I won't be doing every homework problem. And there are going to be some problems that are going to challenge you more than others. Some will be very, there'll be some that are easy, some that are medium, and then, of course, some that are hard. So let's take a look at something like this. This is something that's often missed on the final. We got negative 18 plus 26 minus 7 minus 13 plus 41. But notice what I was saying, that plus, minus. We already said you can't trust those, right? Just because it says plus does not mean the numbers add. Go back to the first few examples. Just because it says minus does not mean they subtract. So let's go through this again and talk positive, negative. Isn't that a negative 18? Doesn't that mean you owe me $18? Isn't that a positive 26? Think about it like a bank account. You withdrew 18, you deposited 26, you withdrew 7, so negative. You withdrew 13, so negative, and you deposited 41, so positive. I would start thinking about these as positive and negative numbers and stop saying plus and minus. Plus and minus just doesn't carry a lot of weight. It doesn't mean much. When you say, oh, I have two positive numbers and we're adding them, now that makes some sense, okay? So here's what I would do with something like this. Try not to bring a new rule into this. Yes, there's more than two numbers, but we can still go through this. Think about it. We got negative, positive, negative, negative, and positive. Didn't we say if we keep the signs the same, they're going to add together? So what I like to do, and this is not required, y'all, I really should have emphasized this from the get-go. If you can already add and subtract positive, negative numbers, then what I'm doing here is not required. This is simply an alternative, not an alternative way. This is simply a way to do it and do it correctly. It's not the fastest way, certainly. It's called the ledger method. I'm going to do it right now. Basically, it amounts to adding up all your debt, adding up all your deposits, and then at the end of the day, just balancing them out. So we're still going to use the same rules we wrote down just a few minutes ago. When the signs are the same, you're going to add, and when the signs are different, you're going to subtract, and you're going to keep the sign of the bigger number. The issue here is there's more than two numbers, and you don't want to just go left to right, because if you do, you might change signs, you might change signs again, you might change signs again, and then you might change signs again. It might jump from positive to negative to positive to negative to positive to negative. You don't want to do that. So here's what I would suggest you do. If you're not comfortable, here's what I would suggest. Let's take all our debt for the day. We spent 18, we withdrew 18, we withdrew 7, and we withdrew 13. Would you agree? Those are the three negative numbers in the sequence, or those are the three numbers that represent debt. What did we say if the signs are the same? Don't they add? Doesn't debt and debt just make more debt? So you owe me 18, you owe me 7, you owe me 13. So in the end, this day, you withdrew 18, 7, and 13, okay? And because they're all negative, we can add those up. 7 and 3 is 10, and 8, that's 18, carry the 1, 1, 1, and 1 is 3. So that gives me negative 38 for the debt, right? Today, I spent $38. I spent $18, I spent $7, I spent $13, so I spent $38. Conversely, over here, how much did I deposit? How much money did I gain today? Well, I deposited 26, right? That's a positive number. I deposited 41, right? That's a positive number. So at the end of the day, I deposited $76. Does that make sense? Think about it. All your negatives put together is negative 38, because when they're all negative, you put them together, it stays negative. When they're all positive, you put them together and it stays positive, right? Positive and positive makes positive. Negative, negative, and negative is negative. Again, when you're adding and subtracting, y'all be careful. When you're multiplying, obviously, it's a little bit different story. Now what? Well, think about it now. Move this off to the side here. Now we have negative 38, right? That was our total in the debt, and positive $67. Negative 38 and positive 67. Think back to the rules we just talked about, because now you have been down to two numbers again. Negative 38 and 67. Are we going to add or subtract those? Well, one's negative, one's positive. You're definitely going to subtract. And make sure that you put the bigger number on top. When you subtract longhand, I guess you could say, the bigger number has to be on top. It does not matter which came first. 7 minus 8, we can't do it. Don't forget how to borrow. 7 minus 8, that turns into 17, which you borrowed from the 6 to make 5. 17 minus 8 is 9, and 5 minus 3 is 2, so 29. Now the issue is positive or negative. Well, we had a negative 38, we had positive 67. The sign of the bigger number wins, so this will be positive 29. So that's our answer here, positive 29. So take a minute, go back through that one, make sure that makes sense to you. You don't have to do it like I'm doing it, guys. This is just my way of, of doing things. It's called the ledger method. Here's my debts, here's my deposits, and in the end, what did I end up with? And again, we just used the same two rules that we were using the whole time. If the signs are the same, you add them and keep the sign. If the signs are the same, you add them and keep the sign. And in the end, we had two different signs, so we subtracted and kept the sign of the bigger number. All right? Hopefully that's making some sense. Let's keep going. One second, get this squared away. Hopefully this is a little better than last time. I talked to the Santa Fe IT people, and they said these cameras are just not great resolution. So unfortunately, it is a little bit of a, it is what it is kind of situation. We'll do the best we can with it though. All right, let's go ahead and go up one more step. Let's bump this up one more time. Let me write another problem down. 14 minus negative 23 plus negative 17 minus 8 plus 29. And again, I say plus and minus, even though I said we should sort of get away from that, because that is what most of us say, right? 14 minus negative 23 plus negative 17 minus 8 plus 29. So what's the difference with this one and the last one we did? Well, there's a bunch of numbers again, a bunch of numbers in a row, just like last time. But this time there are double signs, and that's really the last thing we need to talk about here in terms of what you need to do to deal with these. You probably already know. So let's go through it. 14 minus negative 23. Should that be a positive or a negative? What does that mean, negative, negative? Think about it. If you ask somebody direction somewhere and they told you to take a left, wouldn't that be kind of, you'd be like, what? Well, it's the same thing here. Oh, it's minus negative 23. What? What do you mean minus negative? What does that mean? Well, you probably already know. Negative and negative is positive, right? So we have 14 plus or positive 23. Now, I will caution you about something. Be careful how you explain this. Lots of people like to tell me negative times negative is positive. Well, that's true, but you are not multiplying here. You need to be very clear about that. If you can say that, it seems to work with multiplication, right? Negative and negative is positive. This is not multiplication. So how do you explain that then? I mean, if you want to say negative and negative in your head is positive, that's fine. What I would tell you, though, the real explanation here is you have debt, negative 23. You spent $23, and you are taking away the debt, right? You are subtracting debt. If I took away debt, didn't I give you money? So let's write that over here. If we have a negative and a negative, and you already know this, if we had two positives, it's positive. So if we have a negative and a negative or a positive and a positive, it's a positive number. This double sign stuff is junk. Don't sit with this. Next, same thing here, plus negative 17. What do you mean plus negative? Are you adding debt? Aren't you giving me debt? So aren't you really just taking away $17? And you already knew that probably because positive and negative is negative. So these are the double sign rules. They mimic multiplication. So if in your head you want to call it multiplication, that's fine. We don't need to fix what's not broken here. But I'm just telling you, this is not multiplication. This is not positive times negative makes negative. It does seem to work that way, but you are saying I'm adding debt, so you're going to lose money in the end. Here, the 8, clearly negative. Here, the 29, clearly positive. And hopefully you agree, now we're back to where we were just a few minutes ago. We have no more double signs. Now we can go through and say, well, that's a positive 14. That's a positive 23, negative 17, negative 8, and positive 29. And if you think back to the last problem, you already know what I'm going to do. I'm going to group my like terms together. Here's my negatives. Here's my positives. And because they're going to add, if you keep them with the same sign, it makes it a lot easier, right? Think about what I'm saying. We spent $17. We spent $8. So today, 8 and 7, 15, carry the 1, 25. Didn't we spend $25 today? And then on the positive side, we had positive 14, positive 23, and positive 29. So in the end of today, 3 and 9 is 12, and 4 is 16. Carry the 1, 2, 2, 2, 6, positive 66. So the reason I do it this way is because it's easy to group your like terms together. Negatives group together, stay negative. Positives group together, stay positive. And that means in the end, you only have two numbers, negative 25 and positive 66. So that's really all you need to work out. Negative 25 and positive 66. Think about how you work this out, negative and positive. When we subtract them, so we'll move that over here, 66 minus 25, and be thinking, what's the sign of the answer going to be? Is it going to be a positive or negative number? Why? 6 minus 5 is 1. 6 minus 2 is 4. So we've got 41, and the larger number was positive, so the answer is positive 41. So that should get you through the plus and minus with regular numbers. We still need to talk decimals for a minute, so we're not quite done. But that's the majority of the work. Figuring out how you're going to handle the signs, learning the sign rules, and going from there. How you do this is up to you guys. You don't have to do it like I'm doing it, obviously. I mean, again, remember, there are no calculators used in this class. So if you get lazy and you bust out a calculator to get the homework done in 5 minutes, well, a couple words of warning there. First of all, you are cheating. And if you're caught, obviously the school's going to bring the hammer down. Second, it's pretty obvious when someone's using a calculator because the homework gets done in about 5 seconds. It's really weird. Hey, that's weird. You did 35 problems in 5 minutes. Crazy. Almost like you cheated, right? And the real problem with doing the homework with the calculator is you're going to fall flat on the test. And it's going to be very obvious what happened. So do yourself a favor. Fight through the temptation. Do this by hand. It's a little bit rough, but you can do it. You can do it. All right. So now let's talk about decimals. I'm just going to start you right off in the middle. We're going to jump right into the middle this time. I want you to think about what you do here. 4.05 minus 1919.53. That's supposed to be a decimal. I wrote it up a little bit high. We'll talk more about decimals in next unit, about place value and rounding and stuff. That'll come into play more in the next lecture. For now, we're just strictly talking about how to add and subtract them. And you already know, because this is money. $4.05 minus $19.53. You had $4.05 in your bank account. You spent $19.53, and I'm asking you how this is going to work out. Well, you already know, if you've been paying attention to the lecture, that you have a positive and a negative, so we're going to subtract. And didn't we say the bigger number, 19, has to go on top when we subtract, whether it's positive or negative? The issue is the decimals. What do I do with the decimal? Well, you already know this probably, right? Don't we just line them up? 19.53, 4.05. Notice how I've lined my decimal up, and now we're going to subtract. Because again, positive and a negative, we are going to subtract them. And if you'd like to, it always helps to fill in zeros where there's gaps. It's never a problem to do that. Careful how you subtract. Watch yourself here. It's easy to forget how to borrow. 3 minus 5, you can't do it. That borrows and becomes 13. You are borrowing from 5, which makes it a 4. 13 minus 5, think about it, that's 8, right? 4 minus 0, that's 4. 9 minus 4, that's 5. And 1 minus 0 is 1. So 15.48, hopefully no big deal. I think you know how to add, subtract basic decimals. Not a big deal. The issue is, back again, is it a positive or negative answer? Well, we had a positive $4.05. We had a negative $19.53. Isn't the negative value bigger? So in the end, you owe me $15.48. Just think about it. You had $4, you spent $19, so you overdrafted by $15.48. So the decimals, luckily, are really not a big deal. You simply line up the decimal, and we'll do another example here. You simply line up the decimal and go from there. Let's do one more, one with just 2 numbers here. Just kind of jam it in right here. Let's say we had similar numbers, 19.02 minus 0.037. The difference this time is those are not, one of them is, but the other is not a money number. $19.02, okay, what is this, right? Our decimals don't go 3 places in money. So it's not always gonna look like money. You gotta be a little bit careful. You have $19.02 minus this very small number over here. So again, the larger number will go on top. The smaller number will go on the bottom. Line the decimal up. That's 0.037. Make sure you line up those decimals. And then, like I said, I would go through and fill in zeros just to have everything be nice and even. 0 minus 7. Don't forget how to borrow here. 0 minus 7, you can't do it. That becomes a 10. You borrow from the 2, which makes a 1. 10 minus 7 is 3. But we have to borrow again. Be careful here. 1 minus 3, I cannot do it, so I borrow, and that becomes 11. You do not borrow from 0. It is a 9. You keep going until you get to a regular number. We borrowed from the 9 to make 8. Careful again. I borrowed here to make the 1 11. You're not borrowing from 0. 0 becomes a 9. You can think about it as a 10. It's not, but people say that. What you're really borrowing from is the 9 to make 8. Remember, borrowing is something you're supposed to remember how to do, so brush up on that. 11 minus 3, that's 8. 9 minus 0 is 9. 8 minus 0 is 8. And 1 minus 0 is 1. 18.983. Positive or negative answer? Well, 19.02 was positive. 0.037 was negative. Bigger number was positive. So the answer is positive. So there's two kind of, smaller decimal problems. Let's go ahead and do one ugly one. It's not like the homework's chock full of decimals, but it's good to talk about, right? It's good to talk about. But again, hopefully you're seeing, the idea here is hopefully you're seeing that I'm doing these the same way as I did the other ones. The only difference is, now I'm realizing I'm using the same number again, but that's all right. The numbers really don't matter. Hopefully you realize I'm doing the same thing. I'm going through them, identifying positive, negatives. I'm grouping them together, positives and positives, negatives and negatives, and then in the end, I'm finding the difference or subtracting them. Hopefully you're seeing that. So let's put this all together. We got 1.02 plus negative 0.037. Like I said, I realized I just used the same number again, but no big deal. Minus negative 18. First thing I'm going to do is come through and get rid of the double sign. We have positive 1.02, no big deal. Positive and negative, that is a negative 0.037. Why do I put the dash through the 0? Sometimes it's just habit, but it's a habit I don't do all the time, so it doesn't mean anything, guys. And then negative and negative is positive. So again, the way I would work this out personally is group your like terms. We have a positive number here, a negative number here, and a positive number here. So in terms of our negatives, we only have the 1.037. In terms of our positives, we had 18 and 1.02. Now notice the way I wrote that. Where's the decimal on 18? Isn't 18 the same thing as $18, 18.00? So the decimal is behind the 18, which is why I placed it where I did to line everything up. Remember, when you're doing decimals, they've got to line up. Be careful. 0 and 2 is 2. 0 and 0 is 0. 8 and 1 is 9. And 1 and 0 is 1. Don't forget your decimal. All right. So in the end, we have 19.02 and 0.37. Oh, I think, you know what I think I did? I think I took the numbers from this problem and worked them on the last one. I think I did my notes backwards, guys. Apologies about that. But hey, the numbers are the same, but the principle's the same. The principle's the same, but the numbers are repeating. So apologies about that. I think I got my notes a little goofed up here, but no worries. Nothing's wrong. It's just annoying that I'm doing the same numbers again. It's sort of a waste of time, but we'll go ahead and finish it out. A negative number and a positive number. We just did this, but just to finish the problem out, I obviously wrote my notes backwards here and grabbed the answer first, but that's okay. 0 minus 7. We'll go through this quickly because we just did it. 10 minus 7 is 3. 1 minus 3. Can't do it. So we borrow to make it 11. Again, I'm kind of flying through this because we just did it. Didn't mean to do the same problem twice, guys. So same problem we just did, just sort of building it up to a little bit bigger situation in the start. That's the end of the arithmetic. We have one other thing to talk about for this homework. And this is a little bit less rigorous. We're not going to be doing any math here, so to speak. We're just going to be talking about some concepts, and this will wrap us up. So we're almost done. The hard part's over. The ugly computation's over. The last thing we're going to talk about here is just some vocabulary you need to recognize. There are properties of addition. Properties of addition. Properties meaning things that things that it does. You have the property of being a human. You have the property of being a student. These are descriptors of you. So what can we say about addition? Well, can't we say that the order that you add in doesn't matter? I think you recognize this. I think you're okay with that idea, right? If I had 2 plus 3 plus 4, and I said, is that equal to 4 plus 2 plus 3? Well, it is, right? 2 plus 3 is 5, plus 4 is 9. 4 plus 2 is 6, plus 3 is 9. And so they're equal to each other. So the order that you add in, the order that you write your numbers in does not matter. And this is known as the commutative property. Commutative meaning it moved. The numbers can move and nothing changes, right? Think about what commute means. When you commuted to work today, you drove to work, you moved around. So what this is saying is if you move the numbers around, if it's all addition now, keep in mind, we're not talking about subtraction. If this is all addition, moving the numbers around doesn't change anything. So this is called commutative. The other property, which is similar but not the same, says, look, What if we had something like this? And this is sort of getting into order of operations, right? Right now, there's no order of operations per se because we're only doing one or two operations, addition, subtraction, and neither one comes first. The only order of operations you need to worry about right now are parentheses. So what this is saying is, look, you would do the parentheses first. So 3 plus 5, that's 8, plus 4, that's 12. And on this side, you would do the parentheses first. 5 plus 4 is 9, plus 3 is 12. So once again, these are equal. So what we're saying is when you add, the order that you do the addition in doesn't matter, which is not what I said up here. Here I said the order you write the numbers in doesn't matter. Here I'm saying the order you do them in doesn't matter. This is called the associative property. This is called the associative property. Actually goofed up, that's not a property, that's property. The associative property. And what it's saying is the ones that you associate together can change, and it doesn't matter. 3 and 5 were associated together here, and we got 12. Here, 5 and 9 are associated together first, and we still got 12. So we'll do a practice problem, and this is not a big deal. It's just two different properties. The issue is telling the difference between them. The commutative property, again, says the order of the numbers moved. The associative property says the order that you associated them together changed, not the order of the numbers. Notice it's 3, 5, 4, 3, 5, 4. What changed here was the association. So just make sure you're cool on those definitions. What kind of questions might I ask you on a test about something like that? Because obviously with the plus and minus, you'll just have to work those out. But with the properties, what kind of questions are you going to get? Well, I might ask you something like this. I might say 6 plus 2 plus 3 equals 2 plus 6 plus 3. And I might ask you the following. Is this only commutative? Is this only showing the associative property? Is this showing both properties at once? Or is this showing neither property at all? And it's just two different numbers or two different things that have no bearing on each other. Well, let's make sure they're equal first. Start with the parentheses, right? 6 plus 2 is 8, plus 3, that's 11. Over here, start with the parentheses, 2 plus 6 is 8, plus 3, that's 11. So they are equal, so that's good to know. Is this demonstrating commutativity, associativity, both, or neither? Remember what the property said. Commutativity says the number order changed. Did that happen? Well, for sure. 6, 2, 3, 2, 6, 3, definitely commutative happened. Maybe both. We haven't said it's not both yet, but definitely commutative, right? 6, 2, 3, 2, 6, 3. The number order is different. You commuted them. Did the association change? What's associated up here? 6 and 2. What's associated over here? 2 and 6. The association didn't change. It's the same numbers in the parentheses, isn't it? So the associative property did not happen. Associative property says the parenthesis numbers will change. Big difference here. Commutative says the order of the numbers changes. Associative says the numbers in the parentheses change. Well, that didn't happen. So it's not associative, so therefore it's not both. We already know it's not neither. It is only commutative. Let's do one more, and that'll wrap us up. And these are test questions. You know, these are questions that have appeared on the test in the past. So I do try to let you guys know what's coming. One more, very similar. Let's do -4 plus, oh yeah, right, we can't do negative, so what am I doing? This is supposed to be just addition. Sorry, I'm getting a little ahead of myself. 7 plus 2 plus 5 equals 5 plus 7 plus 2. And again, the same four options. 1, is this only commutative? 2, is this only associative? 3, are you seeing both? Or 4, is this neither? You're not seeing either one, it's just two different numbers. Sorry. Let's try to rewrite that. That was terrible looking. Neither. All right. Did the order of the numbers change? 7, 2, 5, 5, 7, 2. Yes, absolutely. So commutativity happened. Remember, the commutativity means the order of the numbers changed. 7, 2, 5, 5, 7, 2, definitely commutative. Did the association change? What's associated here? 2 and 5. What's associated here? 5 and 7. Well, definitely the association changed. So if these are equal, what we're looking at is both, right? Because the number order changed and the association changed. 2 plus 5 is 7. 7 and 7 is 14. 5 and 7 is 12. Plus 2 is 14. We saw commutativity. We saw associativity. So actually what we saw here was both. So hopefully that makes sense. Kind of a longer lecture, a little bit tedious. Take your time, rewind it, work the problems on your own. Sorry about the goof up with the decimals, guys. I'll try to make my notes a little bit clearer for myself. I didn't mean to do the same problem twice there. A little bit embarrassing, but we are all human. So let me know if this helped. If you need any more clarification, please let me know. And otherwise, I will see you guys on the next one.